Earth is constantly bombarded by solar wind, a stream of charged particles from the sun. Our planet's magnetic field protects us from this barrage, but not perfectly. Some solar wind manages to get through, and when it reaches the atmosphere, it collides with gas molecules. And that collision excites those molecules, causing them to glow. That's why our upper atmosphere shimmers with beautiful auroras. But this phenomenon doesn't just happen on Earth. Any planet with an intrinsic magnetic field gets these beautiful shimmering lights. So it might seem weird that we have auroras on Jupiter too, since it doesn't have a magnetic field. Well, Jupiter actually does have a magnetic field. It's just 20,000 times stronger than Earth's. And because it's so strong, it extends thousands of kilometers out into space, forming a protective bubble around the planet called the magnetosphere. Now, the solar wind can't penetrate this magnetosphere, or at least it shouldn't be able to. But strangely, it seems there are some gaps in Jupiter's defenses, which means some solar wind makes it to the atmosphere and creates auroras. In fact, Jupiter's auroras are more than 10 times brighter than ours. And they're also much more long-lived. They can persist for years before dispersing into space. And one of them has been around for at least 350 years, maybe even longer. It's the largest storm in the solar system, nearly as big as Earth itself, and it's been raging for centuries. Scientists call it the Great Red Spot. So how does a storm stay alive for so long, and why hasn't it died like the ones on other planets? Storms on Earth typically last for days or weeks, but the Great Red Spot has been around for at least 350 years. The first human to spot it was Galileo Galilei back in 1610, and he described it as a small storm that was oval-shaped and about the size of Earth. Since then, it's grown to be twice as wide as our planet, and it's still going strong today. It's located at about 60 degrees south latitude, and it spins counterclockwise. It whips around once every 6 days, and it's not just wide, but tall too. It towers 3,000 kilometers up from Jupiter's surface and extends 3,000 kilometers down into the planet's atmosphere. That's about 40% of Jupiter's total width. So it's no wonder the Great Red Spot is so long-lasting. It's massive, but that's not all that makes it special. It's also incredibly energetic. Storms on Earth typically weaken and dissipate after a while, because there isn't enough energy left to keep them going. The Great Red Spot, however, doesn't seem to be running out of energy anytime soon. In fact, it's one of the most powerful vortices in the solar system, and it sucks up a lot of energy from Jupiter. And it needs all that energy because the Great Red Spot has something in common with tornadoes. Both are vortices, and they both spin. But unlike tornadoes, the Great Red Spot doesn't look like a funnel. It looks more like a giant oval blob. And that's because while tornadoes form over Earth's solid surface, the Great Red Spot forms over Jupiter's liquid surface. When viewed from above, it looks like a gigantic eye staring back at us. But if we were flying through Jupiter's atmosphere towards it, it would look like a towering wall of awfulness. The Great Red Spot is surrounded by dark bands of clouds that rotate around it. And within those bands, the wind speed can reach a staggering 618 kilometers per hour. That's faster than the speed of sound. That means that the air literally roars as it zips around the storm. And that's what gives the Great Red Spot its power. The air isn't just moving horizontally, it's also moving vertically. Inside the eye, the air rises, and outside the eye, the air falls. That creates strong upward and downward drafts that make the storm even more chaotic and powerful. And it's so powerful that it can even influence Jupiter's magnetic field. Now, remember how I said that the solar wind can't get past Jupiter's magnetic field? Well, it turns out that's not completely true. Thanks to the Great Red Spot, parts of Jupiter's magnetic field lines get funneled towards the storm. And that means the solar wind can sneak in and fuel the auroras at Jupiter's south pole. But it doesn't stop there. Some of the particles in the solar wind get trapped by Jupiter's magnetic field. and form beams that shoot down onto the planet's surface. These beams carry about 10 times more energy than the auroras themselves, and they're responsible for keeping the storm going. That's where the energy comes from that allows it to rage for so long. To be clear though, the auroras and the beams are not the same thing as the Great Red Spot. They're separate phenomena that interact with each other. The auroras and beams help fuel the storm, but they don't cause it. The Great Red Spot is driven by convection currents in Jupiter's liquid outer layer. As hot gas from deep inside Jupiter rises up to the surface, it cools off and forms clouds. Then when the clouds become heavy enough, they fall back down into the planet and heat up again. And that cycle keeps the storm going. But these convection currents alone wouldn't be enough to keep the Great Red Spot going for hundreds of years. They'd eventually run out of energy just like storms on Earth. That's where the auroras and beams come in. Let me explain. Jupiter's magnetic field is partly powered by its rotation. As the planet spins, its magnetic field lines get dragged along with it. This effect is called the dynamo effect, and it's what powers Earth's magnetic field too. But the dynamo effect only works if there's electrical conductivity in the planet. And Jupiter's outer layer is so hot that it's electrically conductive. So as Jupiter rotates, the dynamo effect transfers energy from its interior to its magnetic field. And then that energy gets transferred from the magnetic field to the auroras and beams. And that's where the solar wind comes in. Without the solar wind, the beams wouldn't form. And without the beams, the auroras would quickly fade away. And without the auroras and beams, the Great Red Spot would collapse in on itself. So the Great Red Spot isn't a single phenomenon. It's really 3 separate phenomena that depend on each other. There's the vortex, the auroras, and the beams. And it's only thanks to these 3 working together that the storm can live on for so long. For a long time, scientists thought that the Great Red Spot was getting bigger, but now we know that it's actually getting smaller, and that means the storm will eventually die, but not anytime soon. It'll take another 300 years for it to shrink down to half its current size. It's hard to imagine a storm raging for centuries, but it's even harder to imagine a planet without an atmosphere. Yet that's the fate that awaits Mars. Most of its atmosphere got blown away by the solar wind billions of years ago. And that's why Mars is a frozen desert today. If you want to learn how scientists are trying to fix this, I've made a video about terraforming Mars. It's in the first pinned comment. So click on that after this one. All the information for this video came from NASA. If you want to learn more, I'll put a link to their website in the description. This video was made possible by my patrons. If you'd like to help keep this channel going and get early access to every video, you can click the link in the description to find out more. If you enjoyed this video, please hit the like button. And if you want to see more videos like this in the future, subscribe to the channel. Thank you for watching till the end. I'll see you in the next one.